This is problem number 9 from section 3.7. In this problem it says, find the lines that are tangent and normal to the curve at the given point. So they want us to find the lines that are tangent and normal, which means we need to find the slope of the tangent line and the slope of the normal line. Well, all we have to do is find the slope. We'll take the derivative essentially to find the slope. And once we know that slope, that's the tangent slope, and then we just do the negative reciprocal or the perpendicular slope for the normal line. So we're going to start by using implicit differentiation, and you should be able to see why we're doing that. We're using the implicit differentiation because we don't have an equation where we have y as a function of x. So we're going to just go from left to right. You'll notice that we'll have to use the product rule here because we have x squared, y squared. So we're going to say that u is x squared, u prime, find that derivative, then v is y squared, and v prime. X squared, derivative of that is 2x. The derivative of y squared is 2y, but because we're doing the derivative of y, we have to put dy over dx at the end. Let's pull out the product rule. Product rule states that we do u prime v, so u prime 2x times v, which is y squared, so we have 2x y squared, and then we do v prime u, so we have 2y, so plus 2y dy over dx times u, which is x squared, equals the derivative of 49, that's 0. So let's go ahead and combine some stuff together. So we have 2x y squared plus 2x squared y dy over dx equals 0. We're going to go ahead and subtract the 2x y squared over. So let's subtract this to the other side. And we end up with 2x squared y dy over dx equals negative 2x y squared. We're trying to solve for this dy over dx, so we're going to divide each side by 2x squared y. So we get dy over dx equals negative 2x y squared over 2x squared y. This is the derivative. So now we want to know the slope. Let's go slope at 1, negative 7. So if we want to know the slope at 1, negative 7, we're going to go dy over dx equals, we're going to plug in this 1, negative 7, so it's negative 2 times 1 times negative 7 squared over 2 times 1 squared times negative 7. This will give you negative 7 squared is 49. 49 times negative 2, negative 98, over, this will just give you negative 14. Let's see if negative 98 and negative 14 simplify. So we do negative 98, or just let's do 98 divided by 14. That gives you 7, so this is just 7. So the tangent slope is m equals 7, and the normal slope is the perpendicular slope to that. What's perpendicular to the slope of 7? That's just negative 1/7. So now we can actually write the tangent line. So we start with y equals mx plus b. And remember, the tangent line is going to touch 1, negative 7, so I'll kind of write that here. We're using this coordinate for each of these. Let's plug it in. So negative 7 equals 7 for the slope times 1 for the x value. This will end up with Positive 7 subtract over, you get negative 14 equals b. So your tangent line is 7x minus 14. The normal line, you'll do the same thing. We'll do negative 7 equals negative 1/7 times 1 plus b. And then we end up with negative 7 equals negative 1/7 plus b. Add that over. We got to find a common denominator there. That's going to be negative 49 over 7. Add that over. That's plus 1/7 equals b. This is negative 48 over 7 equals b. So that means my normal line will be y equals negative 1/7 minus 48 over 7. This is the normal line.